So in this video, I'm going to do 11.4, the comparison tests. So actually, I'm going to start by probably what is regarded as the easier of the comparison tests, which is the limit comparison test. Still, this is a little different from all the other things you have done, so make sure that you understand it carefully, right? Okay, first of all, you start with the positive series, okay? Suppose you can find another series. I can tell you later how to find this series. Say you call it sigma bn such that limit of an over bn, right, is L where it exists and it is not equal to 0. There's another version of that when it is infinity and 0, but we will do that later. But for the time being, suppose the limit of the quotient, right, of so you start with, so this is your given series, and this is like your partner series. You can find a partner, right, also, right, so that bn is also positive, right, and then limit of an of bn is equal to L. Then we say that sigma an and sigma bn, right, converge or diverge together. What it means is that if sigma bn is convergent, then sigma an is convergent. That's why it's called the comparison test, right? And if sigma bn is divergent, okay, sigma an is divergent. So the whole idea is if you are given a series, you try to find a series which you know to be convergent or divergent, and then using that, you infer the convergence of divergence of your given series, which is sigma a. All right, so let's do an example right away. Okay, so example, check whether sigma, let's say n 1 over n cubed plus 2 is convergent or divergent. So now notice that this is will not cover within. So first of all, let's check all the tests. Okay, let's take the divergence test. Will it work? It will not work. Why? Because the limit of the sequence is 0 as limit an is 0. And then what about the integral test? Well, if you take the integral of x cubed plus 2, right, right, and if you think of it, it will be difficult to evaluate this. So that's also out. What about the p-test? Well, we have, if you had n to the 3, we could have used p-test. But we have n to the 3 plus 2. So for that, we cannot use the p-test. So all these three tests are not valid. Okay. So p-test is not valid because we have sigma 1 over n to the 3 plus 2. And p-test is only valid when you have, if you don't have the two. For example, if you have this, it is valid, but because you have, then you can use the p-test. But if you have plus, then the p-test is not valid. Is everybody okay with that? Okay, all right. So let's, so none of these things will add it. So we are going to try the limit comparison test. So it's always good to test all the previous tests and see whether they work. Okay. Now, if you are using the unit 7, the first thing is to see whether you can find a bn so that the limit an over bn is equal to L. So let me kind of help you to find that. Okay, so what is an? An is 1 over n cube plus 2. So what is bn? That is what we are trying to do now. The partner, the comparison partner, I like to call it. Okay, so the comparison partner sequence. Okay, so or series when it comes to that. Okay, so what happens is what I usually do is I look at this series. Now if you look, the top is 1, so the top is kind of harmless, but if you look at the bottom, right, as n becomes large, it's dominated by the n cubed term because this is only a constant. So when n becomes large, 1 over n3 plus 2 actually behaves like 1 over n cube because n cube is the dominating term. Because it behaves like this when large n, it might make sense to take the bn as 1 over n to the 3. So that is not the given series. This is the given series. This is our comparison partner. Now we need to check whether this is what we need to check before we apply the test. We need to make sure that limit of an over bn is not equal to 0. Only then we can apply the test. Now we are not saying anything about their convergence and divergence yet. We are just checking whether the test, apply the test. Okay. So let's check whether limit of an over bn is not equal to 0. Okay, so an, remember, is 1 over n cube plus 2 and bn is equal to 1 over n cube. So if you take limit of an over bn, that is equal to limit of 1 over n cube plus 2 over 1 over n cube. So this is an, this is bn, right? So now you can take n to the 3 right to the top, and n to the 3 plus 2 is right here. So this goes right to the top, this comes here. Now you know how to find the limit of things like this as n goes to infinity, because what you do is you divide by the highest power of the denominator. You can even use L'Hopital's rule if you like, right? Okay, so if you divide by n to the 3, you get 1 here, and if you divide this by n to the 3, you get 1, plus if you divide this by n to the 3, you will get 2 over n to the 3. So now if you send n to infinity, this goes to 0, and you get 1 over 1 plus 0, which is 1. So it's not equal to 0. So what this says is that the limit of an over bn is not equal to 0. So all it says is that limit comparison test is valid for this situation. The test can be used. Nothing to do with when be used. Okay. And now that we know that it can be used, right, we know that sigma an, sigma bn will converge or diverge together, or diverge together, because that is what it says, the limit comparison test. If you do that, right, they will, if this is not equal to 0, then they will converge or diverge together. What it says is that if sigma bn is convergent, sigma n is also convergent. If sigma bn is divergent, then this is also divergent. But sigma bn is sigma 1 over n to the 3, and from the p test we know that p is equal to 3, which is greater than 1. So sigma bn is convergent from p test, which means that sigma an is also convergent. So what it says is that sigma 1 over n cube plus 2 is convergent. So let me kind of go back to what I did. Okay, what I did was, I want to use the limit comparison test. So I started with our sequence, right, which is 1 over n cubed plus 2, right, okay. And then what I did was I actually found a partner for that, comparison partner Bn, which is 1 over n cubed. And how did I find the partner, right? I looked at how this behaves as n becomes large, okay. So we know that when n becomes large, this is dominated by n cube, okay. So the partner is 1 over n cube because the 2 is not that important. That's how I selected the partner. And then before I use the test, I want to make sure that the limit of an over bn is not equal to 0. So I took the limit of an over bn and so that it is not equal to 0, which is good news because then the limit comparison test can be used. And now, only now, we are checking whether our series, what we want is to check whether this is convergent. But now that the limit comparison test can be used, if the partner series is convergent, we are done, right? Or the path series is divergent, we are done too. But in this case, the partner series is convergent because it's a P series, right? Okay, with P greater than 3. So this is convergent, so therefore this is also convergent. So conclude that. So the whole idea of these problems is to find the partner series first, right? And then compare that, and then make sure that you show that the limit of a n over bn is not 0. Okay. And once you do that, then depending on whether the partner series is convergent or divergent, right? Your series, the given series is convergent or divergent. Let's do another example, right? Okay. So example 2, check the convergence and divergence of sigma 1 over square root n squared plus 2. So for positive and limit of this is 0, so therefore divergence test cannot be used. So divergence test cannot be used. Integral test once again will be too difficult. So we are trying to see, can we use limit comparison test? So we need to find the Bn. So how do you find the Bn? So this is your An, which is 1 over square root n squared plus 2. So again, the trick to finding Bn is when n is large, right? This is dominated by n squared. So this actually behaves a little bit like when n large. This behaves like 1 over n squared, right? Which is, we know that the square root of n squared is nothing but 1 over n. So this is a good candidate for Bn. Again, right? Okay, now we need to test. Before you use the test, we need to test whether limit an or bn is not equal to 0. Okay, so take limit an or bn, that will be limit of 1 over square root n squared plus 2, that is our an divided by 1 over n, which is the limit of n over square root n squared plus 2. Now how do I take this limit? I take the n squared outside. If I take it outside the square root sign, that n squared becomes n. Inside the square root I have n squared is now gone, but because I'm dividing by n squared, I have 2 over n squared. So this goes to 0, right? And this will cancel off. So you have 1 over 1. So this actually goes to 1. The limit is 1, which is not equal to 0. What it means is that the limit, this is great news, limit comparison this can be used. So what it says is that now that you have this, right, you can go to the next, you can write the next statement, sigma b and converge or diverge together. That means if the sigma bn is convergent, then sigma n is convergent, sigma bn is divergent, sigma bn is divergent. But now sigma bn is sigma 1 over n, and that's a p series with p equals 1. is divergent, right? By p-test. So sigma pn is divergent, right? So that means what? Sigma an is also divergent. So sigma 1 over square root n squared plus 2 is divergent. All right, we'll come up with the third example, right? Just to get some good practice on this, right?